Today we'll be talking about robotic force and motion make easy. On behalf of TDS, I'd like to extend a very warm welcome to all of you and thank you for allocating your time to attend this webinar. Okay, we will have our Q&A session after the last speaker has spoken. In case anyone were to forget your questions, no worry, just type them inside the chat room and we will answer it one by one after the last speaker has spoken. And a kind reminder to everybody, okay, remember to switch off your camera mode and mute your mic, okay, in case any unnecessary noise or FaceTime image were to pop up during the webinar. Okay, thank you for your cooperation. So allow me to introduce our new UVC AGV products, okay, which has the technology to kill virus and germs. And when the robot is not operating, you may use the top camera as a temperature sensor to read the person's temperature's reading, okay, and it will alert if anyone detected high in temperature. So we have prepared a simple video for you to show how it works.
UVC is a proven disinfectant against COVID-19 virus. Introducing OnRobot, an anti-epidemic robot. Disinfecting your office during after office hours without the need for any human supervision. Scanning temperature of employees during office hours. With 6 UV lamps and a UV power of 180 watts, OnRobot does a 360 degrees omnidirectional irradiation. Using shortwave UVC, OnRobot is capable of destroying viruses, DNA and RNA in just minutes. Contact us for more information.
Okay, so for those who are interested in our UVC AGV robots, just kindly email to our sales@tds.com or approach to your individual sales and they will give you more info about it. And for those who are not familiar with TDS products, I have displayed up all the brands up here. We are the authorized distributor for the following brands. If you have any projects but you are unsure which product and specs to choose, just speak to us directly and we will guide you slowly in choosing the best product for your applications. Sometimes you do not want to overspend on products that you are not fully utilizing. So just speak to us and we will guide you. Okay. And for those who missed our past webinar, not to worry, just subscribe to our TDS YouTube channel. I've already uploaded the QR code at the top right hand corner. Just use your phone QR codes to scan it and it will bring you to our TDS YouTube channel page. Okay. Okay, this is the YouTube channel page where we will upload all our past recorded webinars videos where you can view all our updates videos about our company technologies. So remember to click subscribe on our YouTube channel. Thank you. So for our next week TDS webinar, we have invited experts from Red Lion to share their flexible, future-proof pack. Okay, it's a single controller pack, a tons of features into a compact package, providing the flexibility needed to solve nearly any networking or automation challenge. What's more, it's been designed to accommodate the future. Okay, Flex Edge makes the technology much better. Okay, and also we have also invite Mr. Sulin, okay, from Zimmer to share on selecting the right end effector tools for robotic systems. They are famous in Germany as their end effectors were supplied to automotive customers who build cars. Okay, finally our webinar is about to begin. So let me check. Hi Branson.
Yeah, hi.
Hi Branson, are you ready?
Yeah,
You
sure.
will be
Let
our
me.
first presenter of the day.
Okay, just give
You
me a
can start sharing
second.
your
Let me
screen first.
share my
Yes.
screen.
While Branson share his screens, okay, let me see. So today we have invited Branson from OnRobot to talk about their intelligent grippers and also how to create collaborative surface finishing applications using OnRobot products.
Okay, hi everybody. Just to check, can you all see my screen?
Yes, Branson, I can see your screen and your
Okay, great.
PowerPoint presentation. So
Okay,
you have
great. So,
on the voice application, including the voice also, right? Because
yeah,
you have some video to show us.
yes, correct.
Okay, so I hand over to you now. Thank you.
Okay, thank you, Max. Okay, so hi everyone. So for those of you who do not know us, we are actually OnRobot. Just a very short introduction. So we are Danish companies doing collaborative end of arm toolings. So not only do we have sensors, we also have grippers and electric grippers as well. So if you are keen to know more on OnRobot, please feel free to check with TDS, or you can actually go into our website, onrobot.com, to actually have a look at us. Okay, so today just talk a little bit on how to create collaborative surface finishing applications with one of our OnRobot products. So we will talk a little bit on our product, which is called the Hex E or the H. So we have two versions of it, Hex E and H sensor. So what is the presentation content that we will cover today? So I'll just talk one pager on OnRobot's vision. And after that, I'll go into understanding of the Hex four-stop sensor. So as you've seen, this is a six-axis four-stop sensor. So it's called the Hex. I'll share some application videos as well, and I'll share with you a success story. Which using our Hex sensor. And after that, we'll go for some Q&As, and after that, I will show a live demo on how easy it is to program the four-stop sensor on a UR robot, because I have a UR robot with me now. So okay, let's get started. So OnRobot vision. So what is OnRobot's vision about? So it's all about building a one-stop shop for enabling collaborative applications. So we want to have an extensive range of products that actually cover all robots, all applications, all accessory types, and of course to all industries. So OnRobot will enable you to actually build highly versatile robotic system. So OnRobot's vision, the main focus vision is actually to be a one-stop shop for all of our customers out in the market. So I'll move down towards the product itself. So just give you a short, brief introduction of the Hex sensor. Okay, so as you can see over here, we have actually two versions actually of the Hex sensors. The older version is called the Hex E or the H. So we have two models for each version. And the newer version is actually called the Hex E and H QC. So what are the difference between the two? Specs wise is actually 100% the same. Specs is all the same. As you can see, the most obvious differences is actually the hardware wise. So as you can see at the bottom, the Hex EH, the older version, this is actually the original design which we have. It is lighter and shorter than the Hex QC version. So we have available robot kits as well, and it works together with a compute box. It's some sort like the brains of this particular sensor. And for the QC version, we call the QC actually stands for quick changer. So we actually have a inbuilt quick changer at the bottom of the sensor, as you can see. So this is actually a manual quick changer. It's not an auto quick changer. So it can work together with any of our OnRobot grippers. So for example, if you want to use a two-finger gripper, you can just click it on, and with just one cable connected to the compute box, you can actually start your programming. So it's really easy and quick to set up. So we also upgraded our connector size to be M12. It's bigger and more durable as well. Okay, so let's move on. Okay, why do we need to use four-stop sensors? So in layman terms, actually these few pictures will actually tell the whole story. So I will not go too much in technical details, just a very brief layman explanation. So as you can see on the picture in the left, so for example, if I want to move this particular block, I want it to go into this hole. Can I do it without a force torque sensor? Yes, it's possible, but I have to teach the robot many positions to move it into this particular hole. But with a force torque sensor, I actually do not really need to program so many points to move it in. All I need to do is actually to set a constant force in whichever direction that I actually need. For this case, actually, let's say we are talking the Z direction, which is downwards. So the robot will actually make use of the force, which is controlled by the sensor itself. It will always press a consistent force downwards, and it will actually move towards the position we've set, and it will keep moving now until it sends, for example, a hole over here, and it will continue pressing this particular cube all the way down till it reaches the bottom. So the force torque sensor will always give a consistent force pushing it towards that direction that you actually set. So in another example, as you can see at the bottom right corner here, we have a concave surface, for example. So as you can see, if without a force torque sensor, if you want to move your own customized tool or something across this particular curve, and you want it to stick to it, it is not really easy. You actually need to create many robot points, waypoints, so that it will actually follow the contour. But of course, with a force torque sensor, it's really easy, as you can just set a consistent, set a force in a particular direction, and it will just follow the contour of it. So this is why a 6-axis force torque sensor is actually very good to use in the market. Okay, so the technology of the force torque sensors that we are using is actually optical. In the market, there's actually a few common kind. We have the capacitive and we have the strain gauge. But for us OnRobot, we are using optical. And if I'm not wrong, we are the only company that is using optical technology. So why optical? It's because it's more immune to EMF. It's deformable. So as you can see, this black color surface over here, this is actually a silicon layer. So let me go back to this slide. Okay, so as you can see on our sensors, we have this black layer over here on each of the versions of the sensor. So this is the silicon that you actually see over here. So inside it, there's actually a light emitter, and we have 4 sensing elements over here. So a very basic function is that the light will shoot the light, and it will reflect on this particular yellow reflective layer onto each individual sensing elements. So when you manipulate the sensor itself, so that means the silicon itself will actually move when you actually use your hands or something else to actually manipulate the sensor. The light reflection will be different, and this in terms it will send back a signal or some data back to our computer box, and from there it will actually calculate, convert it into force and torque values. So this is actually the technology that we're actually using for force torque sensors. So the silicon is there as well to actually be a good protection. So in case if you drop it on the floor, it wouldn't, the components inside here wouldn't break easily. Okay, so which force torque sensors to use? So as I mentioned, we have 2 different models. We have the Hex E and the Hex H. So the differences, let's just talk about the Hex E first. Okay, the Hex E mostly to be used in assembly type applications. It's more on precise applications. So it's always used when oscillation or payload is not an issue. So the Hex E is more precise and remains more accurate for a longer time than Hex H. So rule of the thumb for your own tooling, if you want to use it, maximum payload of 3 kgs and 20 cm length. And for the Hex H, of course, is the total opposite of the Hex E. If you are using it on oscillating applications, for example, like turning tools, polishing, deburring, grinding, anything that can cause oscillation, it is better to use the Hex H itself. It's also good for heavier tools and for fast movement. Why is it so? Because the Hex H silicon is actually harder than the Hex E. So how do we really categorize it? Is the E, we call it elastic, and the H we call it hard. So the hex H is more, it can absorb more vibrations towards the sensor itself. So that's why it's harder silicon. So this is just some of the specs, the data of the hex sensor. I will not go into details on it. I'll just mention the key differences between the hex E and the hex H. So for the nominal capacity, for the forces for X, Y, and Z is up to 200 newtons. And for the torque for XY is 10 newtons, and for Z, Newton meter, sorry, and for the Z is 6.5 Newton meters. This is for the hex E. And for hex H, the forces are exactly the same for compared to the E, but we have a higher torque value for the hex H. So you can see is for the XY is up to 20 Newton meters, and for the Z axis is up to 13 Newton meters. So just go back one slide. So as I mentioned, the hex E is more precise because if you can see the resolution is much smaller. So as you can see for the forces in X and Y is 0.2, and for the force Z is 0.8. Whereas you compare it to the hex H, the X and Y for the force is 0.5, and the Z is 1 Newton. So there's a slight difference in the specifications. So if you're keen to know more on the specifications, please feel free to approach TDS, or you can download the specs from our website. Okay, so what kind of applications is good to use on this particular force torque sensor? Of course, like I mentioned, polishing, gluing, and welding. This is some of the applications that is possible to use. Some of the benefits, of course, is really short programming time for complex path. We have this path recording function. It is only to be used on UR and KUKA robot at this point of time. So later I'll show you what is this path recording function on the live demo itself. So just a short explanation that I can actually use my hand to move the robot to whichever path I want it to go, and from there I can just play this path and the robot will follow that particular path which I have set it to. So the force torque sensor, of course, allows the robot to constantly keep a constant force and speed throughout your whole application. And of course, for deburring as well, you can also make use of a force torque sensor. It reliably follows any kind of difficult contours, saving the time for all the complex programming that is needed. It allows the robot to constantly keep the same force and speed. That is what the force torque sensor is used for. And also short integration and easy programming, especially on the UR itself, because it's a collaborative robot. And of course, for assembly, it is also possible. So as you can see on the right side here, we combine our force torque sensor together with a 2-finger gripper to do an assembly in a PCB. So we're actually inserting a ram into its position. So we can actually set a pushing force, for example, so the insertion is actually automatically corrected. You don't have to teach the robot to actually push the ram into its slot and lock it in. The force sensor itself will actually do up all the work for you. And of course, lastly, you can also do it for quality testing and inspection as well. So some of the examples is like you can actually do a testing of a push button, one of the quality testing. Another thing is that you can actually do testing on, if you have, for the car, you have the signal or the wipers, the shift stick. So you can actually use that to actually test the shifting of the sticks as well. How good is the tension of it? So these are just some of the examples that you can actually make use of in quality testing and inspection. Okay, I'll share with you some polishing application videos. One of them is demo only, and the other is an actual application which was already using in China. Okay, so just let me play this. There's no sound, so I mean there's no talking inside, but there's just some sound. So let me just do a short explanation. So as you can see, we're doing a polishing of a car door. So it's actually, you can see it's not flat, it's curved, and there's a lot of contours on the car door. So what we do is we're using the force torque sensor to create a consistent force in the z-axis, so that you will always press down with a consistent force following the contour of the car. So on a UI, it's really easy to actually make use of this particular function. Okay, so you can see it's just moving around, following the contours, the curves, without actually leaving, separating the tool from the car body itself. Okay, and the next one, this is an actual application in China. So it's a train chassis polishing, or I think it should be sanding if I'm not wrong. Let me just play the video for you. So it's pretty much similar to what we saw previously. So this is just to show you that this is an actual application that's actually being used with our force torque sensor. So as you can see, the train chassis is all curved. So they're using a consistent Z force in this Z direction to press down and do the polishing. Okay, all this motion here, you can actually make use of our path recording function on the UR. So you don't have to teach waypoints after waypoints after waypoints. You can just make use of the path recording and just make the path go to whichever direction that you actually want. So let me share one success story. So this is actually making use of our force torque sensor on a KUKA robot. So this is somewhere in Europe. So they're making use of the KUKA robot to actually do window polishing. So just let me play the video.
We believe that robots should be put to work as service operators, and the first place to start is where people are hanging hundreds of feet in the air. Skyline Robotics, we have a robot that cleans windows. So if we look at a 40-floor building that has roughly 300,000 square feet of window surface to be cleaned, it would take standard work today roughly 2.5 months of actual work to clean. And with Osmo and just two supervisors, we can do that same work in about a week. The robot actually maps the building in 3D as it approaches the buildings. Every obstacle that it might have, like a head popping out the window or window opening, the robot will self-correct and move around it so as not to break a window.
How does it know if somebody's sticking their head out?
Well, it has computer vision and touch sensors, so it can see and feel the building.
I think the first thing people think of when they see this type of system is automation is coming for our jobs. And this probably seems like the perfect example of that. People who probably don't make high wages cleaning these buildings, they're going to be replaced by this robot.
Well, I think eventually society, mankind, will be replacing dangerous jobs because it doesn't make sense for people to be risking their lives. From where we stand, when we look at the job we are automating, it makes perfect sense for us to put the person in a safe position, supervising the robots, and let the robots dangle hundreds of feet in the air.
Okay, so I hope you like that success story that we have. Okay, so that's the end of my presentation. So before I go into the live demo on how easy it is to actually set up a surface finishing application, I will take any questions if you guys have any.
Brandon, the question will be at the last, after last speaker has spoken, so you may continue your demo.
Okay.
Thank you.
So give me a second. Okay, so let me stop sharing so I have a bigger video. Okay, so let me just shift my camera to the robot side. Give me a second. Okay, sorry. So just check. Can you all see the robot and the black color part over here? Okay, can everyone see? Hi guys, can you all see? Okay, okay, great. Okay, so let me just show you how to do. I will do the programming live. So to just to prove the point that it's actually really easy to do. So what I actually do is I have this particular tool over here. So this is just a simulation of a polishing tool, for example. So what I have here is this particular a wavy piece of block over here. So what I will make use of is the sensor will actually just keep pressing down with a consistent force, and you'll follow the contour over here. So just give me about 1 minute to just do the programming. Okay, so I'll just set a waypoint over here. And 0. Okay, so now I will use a path recording, actually, which I have mentioned. So what I will do is I will set the path over here. So I'll just hand move the robot, as you can see. I'll just use my hand to push, and I'm not even touching the surface of this particular block here. So once that is done, I'll stop, and I can move it back to my starting point, and I can actually do a path replay. So this is not the actual running yet. This is just to check whether if your path is correct. So that is done. I will save it, and that's it. My programming is done. So let me just play the program, and yes, you guys can actually see how it. Hope you can see how it actually looks. Okay, so as you can see, it's actually following the contour of the surface, the curvy surface, which I've mentioned. So I'll do another short simulation. So as you can see, if I were to push up the thing, the robot, it will actually keep pushing a force downwards. Okay, so this is what actually the force torque sensor can actually do. So it will always keep pushing down. No matter how much if I push it up, it will still go downwards to that force which I actually set. Okay, so let me just show you how short this particular program is. Can you all see the screen, the programming screen? So as you can see, it's only a few lines, 1, 2, 3, 4, 5. It's just 5 lines, and I can do what looks like a complicated program. It is really easy. So I just need the one waypoint from which is the starting point, and I just need to zero the sensor, and all the work is done from this particular force torque control. So as you can see over here, this force torque control, I can actually set different axes of the force which I want to use. So for example, this particular case, I'm using the Z direction. So I just set a force of 10 newtons, for example, in the Z direction. And the job will be automatically done by the force torque sensor. And also I have this particular thing called the FT path over here, which you can see. So what it does is I can actually, you can see over here in the toolbar, so I can actually use my hands to control at all 6 axes of the robot itself using this particular path recording. And I can also disable whichever axis that I don't need, or whichever axis that I need. One axis only is also possible. Okay, so I think my time is almost up. Then this is the end of my, sorry. Yeah, so this is actually the end of my presentation. I hope you guys have a much better understanding on force torque sensors, why is it important to use or in some applications. And if you have any questions, let's take it on in the Q&A session. So Max, hand over to you.
Hi, Branson. Thank you for your presentations and also your demo.
Yeah.
Thank you. So wonderful demo. Okay, next I'd like to welcome Steven Chong from Mitsubishi, who has more than 20 years of experience in motion. He will be sharing on Mitsubishi Electric latest Servo series J5 and the unique feature of embedded AI in J5 series. He also explained how this feature will help predictive maintenance of any mechanical failure. Mr. Chong, please Hi, Mr. Chong.
Yeah, thank you.
Yes.
Can everybody
Hello.
hear me?
Yes.
Yep. Thank you
Loud
so
and
much.
clear. Thank you.
Yeah. Okay. Let us start. Okay. Thank you. First of all, Max from TDS for having this. Okay. Let's go. Okay. First of all, I'm going to touch on the historical of our server technology since 1990. In 1990, we have launched quite a couple of series: MRSA, MRSB, MRC, MRH, and MRJ. Oh, during that time, right, we are talking about 200 hertz speed frequency, and encoder is about 8,192 pulse per revolutions. As you can see, over the years, right, there is a lot of changes. Let's move on for the next. As you can see, also this is a very dirty driver. I extract this from the maybe eBay or somewhere else. I'm surprised that there are still people that still trading this server because it has been, I think, more than 30 years in the market. Okay, next. Okay, this is second generations. We started with J2 in 1995. Speed frequency increased to 250, and then the encoder also increased to 14-bit. Down after that, this is the smallest series, by only up to I think 40 watt. This is a mini series. Okay, for this 1999, the frequency increased to 550 hertz, and also the encoder bit becomes 17 bit. I think maybe do you all understand about speed frequency response? We basically refer to the speed loop. In every servo driver, there are three loops. We have a torque loop, we have speed loop, also the position loop. So when we measure the performance, usually in the market, we are using the speed loop frequency as a reference. And that has been many years down the road, we are using that. And from 1999, we also have the similar engine. That means the processor inside is the same. We also came up with an MRJ2M, whereby there are multiple axis drive unit, and this is the interface unit. That means it's sharing the base, sharing the bus. So, but this one is a very short life. It's only for domestic market, not so much selling in this region. Okay, after that, we move on to third generations. It was about 2005. As you can see, the speed frequency is going up much faster to 900 hertz, and the encoder become 18-bit. And at the similar time frame, the same generations, we also have some sub-series. This is a sub-series MRES. The encoder is 17-bit, and this is also MRJN, the smaller series, also for 17-bit encoder. Okay. On top of that, we also have 2-in-1 servo amplifier and also micro servo amplifier. Move on from there will be fourth generations. So this one we started in 2011, and the encoder moved on, upgraded to 4 million pulse per revolutions, and this one again from 900 hertz become 2,500 hertz, and the sub-series is JE. JE is because not every application requires such a high resolutions, so this is more for medium performance machines. So the people can actually use this 2000 hertz, considered not bad, and the encoder is actually 17-bit. So in fourth generations, we also come up with 2-in-1 and 3-in-1 drivers to have those compact size amplifier, so that you can mount many axes in the same control panel. Also, we came out with this board type amplifier for micro DC type of servo. Now, J5. J5 is our latest version. As you can see, the speed frequency become 3,500 hertz, and this encoder is very scary. They go to 67 million pulse per revolutions, which is about 26 bit. And as you know, when the encoder resolution go higher, there's less and less people to use power strain to control. They will use network. So network, two types of network is used. TSN, whereby there's 1 giga, and EtherCAT is 100 meg. Okay, and this is a sub-series. JET also launched, and now is a 2,500 hertz speed frequency, and also encoded 4 million pulse. Okay. Okay, this is general configurations of mail server. At the top part is actually all the controllers. For now, I will just introduce the PLC side first. PLC, these are PLC based. We have R series, F series, and then these are the correspondence module for the motions. All right, and this is the network, 1 giga. And for those semicon industry especially, they use mostly industrial PC. So industrial PC, they can use actually EtherCAT. In fact, Mitsubishi also coming out with a industrial PC board for CC-Link IE TSN, but it's not launched at this moment. All right. So once it's launched, we will keep you updated. Okay. At this layer is actually all the amplifier. For N1 is referred to EtherCAT, and for those without N1 is TSN, the latest network. And now I'll go through a brief video. I introduce the one. Design all of the LED for okay. This is the controller PLC base up to 1 giga. We have two types, but choice, and this one can connect to get one. This is why can actually two one. This is the lineup compared to GF4. So everything is increased, more and more models and higher capacity. So your sizing up of the machines become much more right. And this part, this one is actually the future is coming up. We are going to launch a motion software. That means you can install the motion software whereby the software itself will be using the RJ45 in your PC to convert it to TSN, and then you can actually control the server with the normal just a desktop PC or industrial PC. Okay, this is a new feature. Quick, right? And this series is all battery, no battery. Yeah, this part is about the machine diagnostic functions. This is the unique part of entire GFI because this is an embedded AI inside server drive. Okay, later I will discuss this in further more details. For uh, okay. Now, just now the one is a very brief one. Now I'm getting a little bit more details. Okay. For this GFI, it comes with 3 type of server drive: single type, 2-in-1, or 3-in-1. And then for non-network type, that means the analog type, or we call it the power strain type, you'll be using this type, A type. I have to mention is that this point is, as the technology go advance, everything will be more towards favor to the network, because we are talking about high resolutions, much more higher resolutions motor. In order to tap the maximum performance of the motor, you will need to use a command to send command to the amplifier. Let's say you want to go for 1 million pulse, instead of sending the pulse to the amplifier, which is way too slow for that kind of resolutions. Okay. This is the highest so far in the industry, 3.5 kilohertz. And okay, then next. As I mentioned just now, the new features of this series is actually the quick tuning. Quick tuning only takes 0.3 seconds to when you power on, 0.2 seconds is settled. It gives you a reasonable tuning gain response towards the command. This dotted line is the command. And for one-touch tuning, we have been having it since MRJN, MRJ3, and J4 all have one-touch tuning. So when we say one-touch tuning, means when you connect the servo amplifier to this laptop with the software, just click one button, everything tuned. And for J5, this is much more in higher, how to say? That means much more highly responsive. Meaning it's much more comply to the command itself. So with only one touch, right? And for those difficult applications such as gantry base or something, you may want to use the manual tuning. So this again allow you to do multiple axis tuning together. Okay. For quick tuning, this is the one I mentioned just now. So once power on, just 0.3 seconds, everything automatic. You no need to run towards certain speed in order to detect the right gain. Everything automatic in 0.3 seconds once you power on. And as compared to one-touch tuning, you see J4 and J5. You can see that J4 and J5 that this one is still slightly overshoot, and maybe some oscillations here. For those low rigid machines, these are 3-mass system. That means the joint and effector, that side maybe have some vibrations. So all these can be filtered from the server. So, but that time when we J4, they may be still overshoot, undershoot a little bit, or oscillations. But for J5, it further improve. It's getting even more perfect right now. Okay. And also J5, the size is again reduced, smaller. All right. It's same as J4. J5 also have 2-in-1 and 3-in-1, and it give you a very good space reductions for the control panel. And same for the motor. As you can see, the length is getting shorter. All right, compared to our previous generations motor. All right, and there are more and more sizes available. Okay, then Next, I want to introduce is actually the most important development for J5, which is we call it embedded AI. With this embedded AI, we are using MISAP. MISAP means Mitsubishi Electric AI creates the state of the arts in technology. All right. So if you want to find out more about MISAP, you can go to this website. All right. This website will tell you MISAP is not just used in Mitsubishi FA products, robots, or things like that. It's used in our aircon, our automotive components, because Mitsubishi Electric, we make a lot of devices. We make car component devices, airbag system, or those power window or starter system of the car, or many, many more things, right? Those things are elevators, all right? Satellites, all these things, they have a lot of embedded intelligence inside. And for this particular J5, it's embedded with the AI for three mechanical. First of all is the ball screw. Second is the belt. Then the last one is actually the gear. Okay, I'll go through this video. I will go explain it further. Okay, with this type of you know, when you do predictive maintenance in the market right now, we need to mount a vibration sensor, right, to the mechanical things like that. But for our server, we no need. With just our encoder itself is our sensor. The encoder inside the motor able to detect the vibrations, the dynamic frictions of the machines, and from there we can actually tell the mechanical is it in the good condition or in already wear and tear. So we can tell from this MISAP technology. All right. Yeah, this is our and all these tests. Oh, the video like we can tell what shorten out. Imagine we are talking about people like the a very um, big handphone maker in China or things like that. We're talking about the factory size of maybe 1,000 machines under the same roof from beginning to the end of the line. Probably you have to walk 1 kilometer away, and there are hundreds and hundreds of the machines there with many many mechanical parts. It can be ball screw typically, or belt or gears, and they're running 24 hours a day for 7 days non-stop. So you can expect that and server and mechanical is a wear and tear item. Everything got lifetime. So if without any pre-notifications of the ball screw before it fail, there will be a lot of downtime. So unscheduled downtime. So we want to eliminate that. All right. Okay. These are in this case, is tension. Without the measure tensions. Again, it's the same thing. They use a dynamic frictions and also the encoders, top, parameters, top, back. The MISA belt. Okay, the final one is actually the gear. Right, the gear ratio probably is the only thing to do. This case, if we rotate from there, now yeah, it is long, long, and and then that. Okay, these are the three diagnosis. Okay, then this is my last slide. In semicon industry, we're also talking about the very important is the mini size, very small size motor. So in J5, we also have this very small size motor. The series is HGAK series, 25 by 25, 10 to 30 watts, right? But the encoder is not the 26-bit, it's 18-bit encoder, but it's good enough for most of the mini size servo motor. And for motion board, we have a motion board, as I mentioned just now. We have a CC-Link IETSN in the roadmap. Once we launch it, we will update you. So there are differences with a board or without board. I also mentioned we also launched the software. You no need to have any motion board. You can control the servo motor. But again, the performance is different. You see, for control cycle that is maximize the control cycle, you will need the board. Without the board, the control cycle will be longer, but the number of axis is still very big, right? Board type amplifier usually is for those DC server mini size, right at the mounter area, and also we have in Singapore we have acrylic collaborations whereby the ironless, iron core and coreless type of linear motor and DD motor, and also the voice coil is able to connect with Mitsubishi servo driver. All right, this one we come with two choice, acrylic will be TSN and EtherCAT, both are able to control. That's all my presentation. I may check any questions you have. I hand it back to you, Max.
Hi, Mr. Chong. Thank you for presentations. Okay. So now is our Q&A sections. So audience, if you have any questions, you may just type them inside the chat room and our presenters will answer your questions one by one. Okay. So I believe there is let me check. The first question right on top is to Branson. It's asking how many axes in your demo robot for polishing applications? I think that the
Okay.
answer should be 6, right? Yeah.
Yeah, so as you can see, the actual application which we are showing, the one which is the train chassis, that is actually a UR robot, so it's actually a 6-axis robot. And in the first application video which we are showing the demo, that is also a UR, which is also 6-axis. And of course, the KUKA robot with the window cleaning, that is also a 6-axis robot.
Okay, thank you, Branson. Okay, next
Yeah.
I think is Mr. Chong. Okay, someone is asking you any 2-in-1 or 3-in-1 driver for J5 servo?
Yes. As in the presentations, we have 2-in-1 and 3-in-1 servo drive. Yes.
Okay. And I think another question to you is how many network available for J5?
We have TSN, but SSNet 3, no. We don't have SSNet 3 for J5. It will be a change of network. I understand that SSNet 3 is up to 300 mega, but for higher speed, Mitsubishi have finalized to go for next generations of network, which is TSN. And because I think EtherCAT because of widely available for many devices, some customer they still request EtherCAT, although the speed is actually very slow, only 100 meg. So now TSN is 1 gigabit per second. So we already preparing for next generations of technology, which is TSN. We will focus on this part.
And how about EtherCAT?
EtherCAT is 100 is in standard. Is there in J5 we have EtherCAT as well as TSN. Yes, it's different model. The amplifier is different model.
Different model, okay.
Yes.
So does next also to you as well. J5 provides 10 watt and 20 watt servo motor.
Yes, J5 amplifier is going to be able to mount with 10 watt, 20 watt, and I think 30 watt as well. The motor. Yeah.
Oh. Can support pretty small servo motor lah. Okay.
Yeah.
Thank you, Mr. Chong. Okay, I think next question is to Branson. Okay. Someone has asked. Hi, Branson, you there?
Yeah, I'm here.
So
Okay.
the question
So
to you is, can this force sensor guarantee the end effector is perpendicular to the curved surface?
okay, so of course, the force sensor will always be pushing a consistent force to whichever axis that you're setting. Of course, the important thing is that your TCP of the robot, you have to set it correctly so that it will always be perpendicular to the curved surface. So like you saw in the first demo video on with the car door. So as you can see, it is always perpendicular, although it looks like a curve, but because of the robot's position that you set the position to, it looks like a little bit curved. But as you can see, the polishing tool itself is always perpendicular to the, or should I say, parallel to the car door itself. So I hope this answers your question.
Okay. So does it matter how much the curved surface be? Any angle should be okay, right?
Yeah, as long as you teach the robot correctly, the set the TCP correctly, and you teach the robot's position correctly, the path or the movement, it will always be perpendicular to the curved surface based on the force which you actually set.
Okay, thank you, Branson. So I hope that answers the questions for all the audience questions. So is there any more questions before we end our day? Let's see, 1 or 2 minutes more. If not, I think there's one more. Okay, so hi audience, we have already posted our next week events. So do remember to click on the chat room, the link, and register for our next week events webinar. Okay, if not, thank you, ladies and gentlemen. We have come to an end for our webinar. Thank you very much for your participants. And I'd like to thank you all speakers as well for your presentations. Thank you.
Thank you, Max.
Yes,
Thank you.
Thank you,
Mr.
Max.
Chong.
Thank you.
Hey, thank you, Branson. So I hope everyone enjoys the program. And if anyone has any questions or further inquiry, just email to us and we'll approach to you individually. Okay? Thank you and see you on our next webinar.